So Python can be used to glue together lots of stuff and to build lots of tools on your own. But one of the great things about Python is that it is, at this point, one of the most popular languages in the world, probably the most popular scripting language in the world. And people have built out all kinds of toolkits that you can use in order to make it do all kinds of things that it wasn't originally intended to do. In fact, a lot of what we'll do from here on out will be using these toolkits in one way or another so that we don't have to build from scratch. When I started out using Python, this was back in the Neolithic period, not quite, but about 20 years ago. All these toolkits didn't yet exist. And so if you wanted to do something like build something to scrape something off the web, you had to do it from scratch. As we'll see, there's lots of tools now that will help us do that much more easily. One of the ways we do that is at the beginning of our program, we kind of unpack the tools we're going to use by importing various modules. Some of these modules are built into every installation of Python, and some are ones that you need to download and install on your computer, for example, if you're doing things. One of the ones that's on every installation is math, and it's very easy to import this so that we can use it. We simply use the word import and then the name of the module, import math. And now, when we run this, we have a whole bunch of new tools that are sitting there ready for us to use. So, for example, I can find out what pi is. Instead of having to do it myself, I can just say math pi. And it will give me that value. In this case, it's not a function. It's actually a constant kind of a form of a variable there that we can use in order to solve things. And it's sitting there kind of within math. Or I could do the square root of 25, right? And it would produce an answer for me. Or I could do, make it a little more complicated and do a factorial of 25. And it would give me a very large number, which is the factorial of 25. So there's a whole bunch of, all of the things that you would expect to find in a bigger calculator sit in the math function. Normally, that's what you do. In many cases, rather, that's what you do. You import the entire library. But because this is a big library, what if you're just doing something where I'm going to go ahead and, because I've imported this, I'm going to unimport it by basically doing a reset of the entire runtime. So this is going to kind of get rid of the things that I've imported and start me back from scratch. What if I didn't want to use the memory it takes to import that whole thing? In that case, I can just import the components, the pieces, the objects that I need. So I could say, for example, from math, import pi. Now, remember, on those last few examples, I was using math.py because I needed to say I'm looking for something in that library that I've imported, right? And in this case, I'm not going to need to do that. I'm going to have imported it, so I can just say pi. It's kind of imported by itself because I don't need to use the math piece because I haven't brought in the whole library. So now I have pi right there. Another alternative is if I don't want to use the words they're using, I could import it as poo. I'm not sure why I would do that necessarily, but I can change the names of things. There is a reason for this. For example, if you are working with two different versions of something, one that does sign in one way and one that does sign in another way, you might have multiple sorts of either constants in this case or methods or objects that all share the same title, and you want to avoid that, so you can kind of do it this way. And now if I do poo, oops, it doesn't like poo. Let's see how it feels about that. It kind of has assigned that value that was pi to poo. This can be true for, like, if I didn't want to call it SQRT, if I was going to use it over and over again, and this would be a really bad idea, I could actually import, well, I'll do it real quick. I'm not sure if this will work, but let's try. Again, we can't break these things. So I'll, from math, import square root as s. Again, it's a really bad idea, but now we can do s of 4. It knows up there that it's a square root, but s of 4 gives me 2. So we can kind of do that. So that's a very basic, straightforward way to do this. Let's play with this a little with some of the things that we've already encountered. Let's do a, let's try importing something called Colab Turtle. And I don't think we'll be able to do this, but let's find out. So let's try importing Colab Turtle. So it gives me an error here. It says the module is not found. So we're looking for this module, but that's not a module that exists on this particular virtual machine. Now, I'm going to use this. So this is specific to Colab, okay? This is specific to Google Colab. You can use the little exclamation point to basically execute commands on this virtual machine we have. Outside of Python, outside of the Colab kind of shell, outside of the IDE, we can do sort of Unix or Linux-like commands on that machine. Later on, not in this introduction to Python, but later on, we'll actually be playing with a number of different Python commands that are useful to us. But for now, we're just going to issue this one command, which is pip, which is the Python installer. And we're going to install this module that we don't have on our machine right now. So this is going to go out, and we'll run it real quick, hopefully. So it's going out, and it's actually downloading this module from the web, and it's installing it on our virtual computer here, so that we have a new module that did not exist before, is now on our virtual computer. If we were doing this on our own laptop or whatever, we would follow a very similar process of opening up a console of some sort, and or on Windows this would be command, or dropping into a console of one form or another, and installing the software on the module on our machine. In this case, we've just installed the module on the virtual machine that runs Colab, our instance of Colab. And we're going to go ahead and do a particular kind of import. And what we're going to do is from collabturtle.turtle. So this little piece of Colab Turtle called .turtle, and there's other things that we're not importing. We're going to import everything. Now, what does this mean? It means that when we do the other commands later on, we don't need to type, for example, collabturtle.turtle.initialize. We can kind of skip some of that because we won't have to have all those dots to make it work. So let's start with that. And then, again, we don't have to type collabturtle.turtle.this, which is initialize turtle. Oops. So initialize turtle has created a turtle. Now, for those of you who, depending on when you went to school, you may have been exposed to the Logo programming language, which was a turtle-based programming language to kind of teach people how to program. But we can move this turtle around the screen by typing commands. Oops. And so it moves it up by 20 steps. Let's see, we could... It's actually moved it up by 40 steps. This is a little tricky because I've done it in the same place and it's keeping track of where the turtle is. We can now make a right turn. Let's do this. Let's see, if I do it in here, I can still do this. Let's just do it this way. We'll do right 90, forward 40. We'll keep doing that a couple of times. I'm just going to copy paste. There's another way we could do this besides copying and pasting. Let's see, forward, forward, forward. That should do it. So we've made a nice little 40 by 40 square, right? Now, as I said, we could do this a different way. And we could do it using a for loop. Now, I'm going to really quickly show you a for, and I warned I would do this before. I'm going to use I, which is just a terrible name for a variable, but it's an index, and so it's a bad habit of mine. But I'm just going to call it I in range 5. This is kind of a callback to our last lesson. We're going to kind of just print I real quick. So the reason I'm doing this is I'm letting you know sort of how the range function works. Range kind of, it doesn't quite do this, but it's easy to think about it this way. It creates a list of the numbers from 0 to 5. If you wanted to start with 1, you could actually, or 0 to 4, up to 5, right? So if you wanted to do it, you could do 1, and then it would start with 1, and you can also have it do skip. You could have it skip ones in between there and stuff like that. But generally, so this starts us with 1. So it goes from here up till this number. And if you have another number in there, well, if we did it to 10, I guess, we can do that. This counts by 2s, right? But usually you're just using one of these. And in this case, I'm going to do, I want it to do the same thing up there. I did copy, paste, copy, paste, copy, paste to make it do I didn't do the first forward because it was already done, but I did copy, paste, copy, paste, copy, paste to do things. I could, for example, have it go 360 times. Think about, let's do it instead 90 times. And what we'll have it do is go forward once, and then make a left of 4 degrees. So if your math is good, you know that you're going to make a total of 90 4-degree left turns, and you'll end up back where you started. Let's see if this works. It's moving very, very, very slowly. This isn't exactly the kind of thing that I suspect Colab guessed that people would be doing with Colab, which is graphical interfaces that are moving. It's just not really what it was built for, but it still manages to do it very, very slowly. If you did this on your own machine, it would kind of do this instantly. Like you wouldn't have a chance to see the turtle moving through its 90 steps. I feel like we should stop the poor thing, but instead I'll do our next step, which is we could do something similar, but make a prettier design. We could make like a flower or something. Let's let that keep going, and we'll do a different code. This time we'll cut our steps in half in hopes that it'll go a little faster. Let's do 45 steps instead. We'll do 8. So in this case, let's go forward by 100 and left by 8. Think for a second and see what that'll do. Actually, let's do left by 172. So that's an almost 180, but shy by 8 degrees. So let's try that. I didn't think about it. It's going to center around that, so I'm going to actually double up. Oh well, that's okay. You get the idea. So this is a pretty much impractical module. Like I doubt you'll ever actually use the turtle for anything. I mean, you could if you wanted to. There's other ways to draw in Python. There's a number of things that we aren't going to touch here because we're not really interested in making games, or I mean, you may be interested in making games, but the topic that we're engaged in isn't really around making games or making user interfaces. So the graphical piece, we will be touching on visualization eventually, but we won't be doing this kind of interactive graphics type things. So so this is really was just an opportunity to show you how to do some of the things we've done up here, which includes importing things and in one case installing things to our virtual machine, eventually to a practical machine. All right, thanks.